Hello and welcome to SudoKanard. Let's have a look at this multiple Sudoku by American author Thomas Snyder, who created this magnificent round of WPF Sudoku Grand Prix. This was the highest pointer in the round, but not necessarily the most difficult puzzle, I should say. Well, so the rule, I just recapitulate what it's all about. Whenever you have a clue in a circle between two cells, it means that the two-digit number formed by the two cells is a multiple of the number in the circle. For example, this must be a multiple of 7, this must be a multiple of 8. So let's start. Obviously, a multiple of 5 will end with 5 or 0, but 0 is not allowed in a Sudoku puzzle. And multiples of 8 must end in an even digit. So I used some coloring. I did it somewhat differently on paper with E for even, O for odd. I could have used P for pair and I for impair, because that's how we say those things in French, but I truly did it with O and E. So let's do some parity coloring. So obviously these are odd, and I use purple for odd and green for even. So all of those are even. Like this, and I don't think I overlooked any of them. Now 9. Divisibility by 9 commands that those two add up to 9, so this must be odd. And there's more to see. On this row we already have 4 even digits, so the remaining digits must be odd. And is there anything? Right now I'm not seeing anything more, but we'll come to that in a short moment. All right, so let's see about this. What are the two digits number formed with two, the multiples of 7, sorry about that, with two even digits? With a 2, we have 28. With a 4, we have 42. With a 6, we have, 63 doesn't work. With an 8, we have 84. So the question is, obviously one of those three two-digit numbers is to be placed in here, and here we must have the other two even digits, and 6 is one of them. But if I try to put a 6 here, then no even digit will work. 26, 46, 86, none of them is divisible by 8. So 6 has to be here, and only 64 will work here. So the remaining digits must be 2 and 8. So this is actually 28. So that's a really neat start. Now, something that is to know, I think, something that's important to know whenever you have a multiple of 4, not only multiple of 8, is that if the unit digit is itself a multiple of 4, like that's 4 and 8 and 0, then this digit here must be even. So here it will be 2 or 8. But then 84 is not a multiple of 8, so that has to be a 2. And those are 6 and 8 as a result. And likewise, here we must have an even digit, so it should be 4 or 6, but 68 is not a multiple of 8, while 48 is. So let's do some more coloring. And on the other side, if this digit is even but not multiple of 4, that means 2 or 6, then the 10th digit must be an odd digit. And actually here we can see it's 16, 56 or 96, and here that's 32 or 72. They'll need a lot of theory in this case, but that's something more general. All right, so this column now has 4 even digits, so the remaining must be odd. This column also has 4 even digits, the remaining must be odd, and this multiple of 7 is interesting. Here we have a 6, and actually those must be odd. And here we have, well, I said this must be a 6, and then this must be 1, 5, or 9. That's an 8, and that must be a 4. And the rest of this row here must be odd, that's even. Because of 9, those must be even. And actually this one is an 8. So this is 2 or 6, and this will be a 7 or a 3, 27 or 63. Up there we get a 2, 6 pair. That's 4 or 8, we'll come to that. Yes, and because it is 4 or 8, this has to be even, and the only possibility is 48. And here we get some more odd digits. This, I'm sorry about that. This here must be a 2, and this is now 3 or 7. What has happened? This is a 1, obviously, and this is 5 or 9. This is now 2 or 6. This is another even digit, and this is odd. And then, where should we look for more? Here seems a right place to look. So this is 2 or 8. But 8 here, we need a 4 there. So that's a 2 with a 3 or 7. This is 4 or 6. 4 here would work with 64. 6 would work with an odd digit. Not much to say about that, I think. Here, so this is 2 or 6, so this is an odd digit. Let's mark that. What about this digit? This digit now must be 4 or 6. 4 here works with a 6 there. I'm not seeing anything more around this. Here there's something interesting. One of them is an 8, so one of them must be a 4. Which means that the remaining digits in the box must be odd. That's correct. On this row we still need a 6 somewhere. But actually, I remember that. A 6 here would need this to be a 5, which would be great. So 6 is actually here, which resolves the 2, 6 pair, and that's a 3. And that's 7. Yes, I remember this step in the solve. So that's an odd digit, and I'm not sure I can deduce anything about that. Well, let's just see that this is from 179, but 7 doesn't work, because there would be no valid choice for this digit. So with the 1 here, what do we have? This could be 21, this could be 91, this could be 49. That's not so interesting, actually. No, that's really not that interesting. I have to try. What then? Oh, this must be 3 or 7, so that this here is 1 or 9. And there again, this being 1 or 9, this must be from 2, 4, 9, but actually 2 is not available, so it has to be from 4 and 9. So 49 or 91, and that's interesting because there is a 9 in those two digits, so that this is a 5. and that's a 9. So here we get 1, 5, and 7. And the remaining 2 digits in the row are a 3 and a 9. Here, those are from 3, 7, and 9. And that should be interesting. Because now, what are the options? Those options include 1 and 5. 1 and 5 must be in here. And at least one of them is in here. And knowing that at least one of them must be in here, the other digit will never be a 3 or a 9. If you put a 1 here, then this actually must be a 5. If you put a 5 here, then this must be a 1 or a 7. So there's never a 3 or a 9 in here. So they must be from 1, 5, and 7. And 5 is compulsory. Oops, sorry about that. Yes, 5 is compulsory together with a 1 or a 7. So 15, 55, 51, or 75. And this could be any other digit, I'm afraid. No, or not sure about that. But we don't know about this. No, we don't know about this. This should be an interesting place to... Oh, I'm missing something. We know that there's a 9 here, so this is never a 9. Well, that was not spectacular, I guess. This multiple of 7 is interesting. It's made of 2 odd digits. So, with a 1 here, no, 14 doesn't work. With a 3 here, 55 does work. So 55 is an option. With a 5 here, that's 56. 7 doesn't work, we already covered that. With a 9 here, it could be 91. So that's like this. That's not so spectacular again. Where is the next place to look? I feel like I'm missing something. Something deep. Oh, I've been missing this. This column needs an 8. And that's a 4, and that's a 6. And this is now from 1, 5, and 9. Let's do some more coloring. That's it. Oh, and this now is a 4, which makes this a 6. That will be interesting, I think. I still need an 8 somewhere here. I'm not sure about where to put that 8. But then I said that's interesting, because now, knowing that 2 digits from 1, 5, and 7 are here, the 2 other digit can only include one of them, but with one of them, the other digit must be 3 or 9. And if one of them is 3 or 9, then the other must also be 3 or 9. I really like this kind of argument. So now we have a 3-9 pair here, so this is 7, this is 3, so that's 9 and 3. That's 7 here, so that's 2, 6. We'll come to them later, so that's 8, that's 6, so 4 is here, that's the 9, that's the 1. That's not the 3, obviously. And this is actually 9, so that's 7 and that's 3. 7 is not here. That can only be a 4 now, so that's a 9, and this is all consistent. Here I need 2, 7, and 8. 8 is not here. So that's not 27, it uses an 8, and only 8 and 7 work. 8 and 2 don't work, so that's a 2. 78 and 87 are both multiples of 3. That's a 6 now, together with 1, 5 or 9. And there's a 1, 5 pair here, so that's a 9. We still need a 3 somewhere, it can only be here, and that's 7 or 8. There's a flurry of activity all of a sudden. This is a 3 now, with 7 here, which resolves the 8-7 pair. 3 here is not here, and it must appear on this row, so 3 is here, and that's 35. Which resolves the 1-5 pair, that's not a 5. This can only be a 1, and that's a 9, and that's 8. Multiple of 3, 81, 84, 87. And that's a 5. So no 7 here, no 5 there. So that's a 5. This column needs 1 and 2. Here there's a 4 somewhere, it's here. That's also 1 or 2. That's a 9. This is 1 or 5. And what about this? This has to be 32 or 72, only 3 is available. This has to be 15 or 56, 16 or 56. There must be a 9 somewhere, it's here. That's a 1, that's a 5. 1 and 5. 1, 2 and 3. 3 is not here. That's a 1, that's a 2. And the rest should come very smoothly. 8 is here, and 7 is there, and that's it. So, excellent puzzle. Sorry for not finishing the coloring. That's really unnecessary at this point. So, really, really neat puzzle by Thomas Snyder. With a lot of interesting use of odd and even stuff. And what are the multiples of 7 with 2 odd digits or with 2 even digits, the multiples of 8? That was a very clever construction. I loved it, yes. I loved the whole round, to be honest. Thanks for watching this video, and see you soon on SudoKanard.